In this video, we're doing improper integrals, and we have an infinity between the bounds. So if we look at example 1, and we think about 1 over x to the fourth, we are undefined here when x equals 0. And notice that x equals 0 is between -2 and 3. So we have an infinity in between the bounds. So what we're going to need to do is split this integral up into two pieces at that x equals 0 value. So our first integral is going to be from -2 to 0 of 1 over x to the fourth dx. Our second integral is going to be from 0 to 3 of 1 over x to the fourth dx. We're now going to take the limit of both of these, and if either one of them is divergent, then the entire problem diverges. So maybe we'll get lucky and we'll get a divergent right away. So let's start off with the limit as L approaches 0, and I'm going to start with this first one. So we're approaching 0 from the left side. We have the integral from -2 to L. I'm going to think of that as x to the -4th dx. Now if we integrate x to the -4, we end up getting, we have the limit as L approaches 0 from the left side, and that would be -1 over 3x cubed from -2 to L. So now we've got the limit as L approaches 0 from the left side of -1 over 3L cubed minus -1 over 3 times -2 cubed. Well, the front part of this is going to be our problem, because obviously if we're approaching 0 there, we're going to end up with some sort of infinity, which is going to be diverging. Let's do another example. So in example 2, this one's a little more difficult to think about. Again, we're worried about when will this be undefined. Well, it'll be undefined when you get a 0 on the bottom. Well, if you think about it, in order to make a 0, e to the x would have to be 1. Remember that anything to the 0 power is 1, so therefore when x is 0, we have a problem. So let's rewrite this as two integrals. We'll go from -1 to 0 of e to the x over e to the x minus 1 dx, plus the integral from 0 to +1 of e to the x over e to the x minus 1 dx. Again, we're going to do separate limits, and if either one of them diverges, then the entire thing diverges. So let's see if we get lucky again. We have the limit as L approaches 0. Since we're doing this first integral, we're approaching from the left side, so -1 to L, e to the x over e to the x minus 1 dx. Well, let's do that as a u sub. I'm going to bring that over here. We have e to the x over e to the x minus 1 dx. If u is e to the x minus 1, du is e to the x dx, and of course we have that, so this becomes 1 over u du, which is a natural log. So we now have the limit as L approaches 0 from the left side of the natural log of the absolute value of e to the x minus 1 from -1 to L. So now we've got the limit as L approaches 0 from the left side of the natural log of the absolute value of, we're going to put in e to the L minus 1 minus the natural log of the absolute value of e to the -1 minus 1. So now when we plug in our 0 here, notice we're getting the natural log of 0, which is an undefined or an infinity. So once again, this one diverges.